Welcome to second in the series of videos on power. This video is slightly a detour from your typical textbook definition of power. Here we're going to look into some real life scenarios. We have this is a battery replacement for a mobile, and this is a adapter. So these are all power sources. So let's look at first the specification for the battery. So the first one is, it says the capacity of the battery is 3210 mAh. So when we say capacity is 3210 mAh, what we are saying is, hey, this battery can hold 3210 milliamp, or it can deliver 3210 milliamperes. If it delivers, it will last for 1 hour, right? Or in other words, that'll be about 3.21 amperes, because that's milli, it's into 10 power minus 3 into 3600 seconds. Now ampere is nothing but 3.21 coulombs per second it can deliver into 3600 seconds, and that would amount to let's calculate what that'll amount to. It's 3.21 into 3600, and that's about 11556, 11,000, approximately about 11,556 coulombs. That's the amount of charge that it can deliver over the full charge. So that's what the capacity means. The second, what you have here tells us how much energy it can deliver. So let's look at that. You have the energy is given by when they say 12.35 watt hour, they imply energy, because you can see that that's equal to 12.35 watts is joules per second, into hour is 3600 seconds, and that'll be about 44,460 joules. So that's the amount of energy, net energy, that battery can deliver. If you go further down, you have the nominal voltage. So this is the operating voltage of the battery. So that'll be about, so if your operating voltage is 3.85 volts, so your average power, so your whole power will be equal to energy by time, and we know that the energy it stores is about approximately 12. So let's say 12 watt hour divided by 24 hours. So that's about 0.5 watts. That's the amount of power that your battery is delivering. And the average current, once you know the power, you can find the average current. Oh, this is the average power. So your current, again the average, the average value, sorry, let me pull this down. Yes, so your current average would be equal to power average divided by the voltage. That's 0.5 divided by 3.85. that'll be equal to 0.13 amperes, or in other words, you can say it is about 130 milliamperes. So that's a power that's a average current that you're drawing. Now all batteries have an ability for delivering some peak value of current. So let's say the peak battery that it can deliver is 1000 milliamperes, but on an average you're using about 130 milliamperes, right? By the way, I just want to go back to this quantity, 24 hours. This is based on an assumption that your battery discharges in 24 hours. So if you have that much energy and your battery discharges in 24 hours, so on an average your battery is delivering 0.5 watts. So this is how you can analyze what happens in your battery. Now let's look at one more use case of analyzing your adapter. So your adapter is a very different scenario where you use your adapter to charge the battery. So in your adapter you will have two kinds of specification. One is your input voltage. Now this input voltage is, it says it's about let's say 100 to 240 volts, and it can deliver 0.55, or it takes in about 0.55 amperes to 0.25 amperes from the wall, from the power that you get at your home. So this amounts to the power that it amounts to taking in is about 240 into 0.25 amperes. So that's VI, that's the power consumed. That's about 60 watts. Now the output power that it delivers is, it takes AC and delivers DC. So output power delivered would be equal to 15 into 0.6 15 volts into 0.6 amperes. Sorry, that should be 0.6 amperes. That's about 9 watts. So the question is, what happens to the difference of energies? So it takes in about 60 watts and delivers about 9 watts, and rest of the energy is actually what actually heats up the adapter. So that's why your adapter heats up, because the amount of power it takes in is much more than the amount of power it delivers. Now let's try to understand the specification from a consumer point of view. So here is a specification of a geyser. You can see that this is a snapshot from Amazon, and it says wattage is 2000 watts for about 25 liters capacity. Now when you say 2000 watts, so the power is 2000 watts, and if it operates against 240 volts, so V is 240 V, the current will be, or let's say the safe current, let's say the safe current, safe current is given by the power divided by the voltage, because as you know the power is equal to VI. So this is a safe current that you can pass through that equipment, and that will be equal to 2000 divided by 240 volts, and that's equal to 8.33 amperes. So how do you ensure safety? Is by attaching a fuse with a current rating of 8.33 amperes. So you will look at that in your household circuit chapter. But let's see how it's done briefly. So you will have a switch, and this will be a live wire connected to the switch, and then there will be a fuse, and a fuse will with a current rating of, let's say, 8 ampere. If your safe limit is 8.33 amperes, let's say it's 8 amperes. It's a little less than the safe limit, and from here you will have your geyser, and the other end of the geyser is of course connected. This is your live, and other end of the geyser is connected to your neutral. So that's how you protect your equipment. The safe current would be the power rating of the appliance. So this is a power rating of equipment divided by the voltage rating. So the voltage rating. So every equipment has a voltage rating as well. So equipment sold in India will have about 240 volts. Now let's do an interesting problem to understand the idea of operating voltage. So let's assume that you purchase a bulb. So this is a problem from consumer point of view. A bulb of 100 watts designed to be operated in 220 volts. And you take this bulb from India and you put it in US, will be about 110 volts. The question is, find the power of the same bulb. Okay, so this is the same bulb. So if the bulb is A, this bulb is also A. The only difference is this is India, this is in US, where the power is 110 volts. So for this, first you need to look at this, what is constant in US and India. And what will be constant is your resistance. It will be same. It won't change because it's a property of the material. And let's look at the bulb designed in India. You will have power is defined by V squared by R, or in other words, R equal to V squared by P. That will be about 220 the whole square divided by 100. That will be equal to, so this 484 ohms. So that's your resistance. This is 484 ohms. Now you take to US and you plug this resistance into 110 volts. So your power output, the power output would be equal to V squared by R, and that'll be 110 squared divided by 484, and that's equal to 25 watts. So you take this 100 watt bulb in India and you plug it in US, your power output of that bulb will be only 25 watts. I hope you found this video informative. See you on the next one.